Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR June 2022, paper 4, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1a, write 6,050,000 in standard form. Okay, well, standard form consists of two parts. You've got like a mantissa part, which is a number between 1 and 10, and then times by a particular power of 10, so a times 10 to the n. That's the sort of format that it's in. Now this part here, the a part, you get from the digits of your number, but you rewrite it as a number between 1 and 10, don't you? So rather than having 605, we're going to have 6.05. Okay, and then the power of 10 that you need is how many places your decimal point has shifted. So the decimal point started here and it's going to end up here. So it's kind of shifted 1, 2, 3, 4, 5, 6 places. So this is 6.05 times 10 to the 6. Okay. It's sometimes handy to remember these powers of 10. 10 to the 6 is always millions. 10 to the 3 is thousands. So you kind of get used to them over time. Write 4.58 times 10 to the minus 3 as an ordinary number. Right, now again, this bit here is going to be my digit. So it's going to have a 458 in it somewhere. Okay, but I've got times 10 to the minus 3 here. Now the way I remember this is, for negative numbers, you're going to have 3 zeros. If it's 10 to the minus 3, you're going to have 3 zeros before you start writing your number. So 1.23. So I'm going to have 3 zeros. 1, 2, 3. 1 in front of the decimal point and 2 after, and then the digits from the mantissa appear here. Okay, so it's 0.00458. Question 2, calculate 270 over 2.5 squared minus 4.6 plus 17.2, all divided by 8.4 minus 6.8. Now this looks horrendous, but this is the calculator paper, so as long as you can type that carefully into your calculator, it should be no problem at all, should it? Okay, so I'm going to use the fraction key. I'm just going to try and write it into the calculator just as it appears on the page. Going to use the fraction key, going to write 270 on the top, press down key, 2.5 squared on the bottom. Now to come out the fraction, I need to press the right arrow, and then I can put the minus sign in, and then I'm going to put another fraction in, and then I'm going to put 4.6 plus 17.2 on the top, and 8.4 minus 6.8 on the bottom. Right, what's that equal to? 1183 over 40. So 1183 over 40. So that's a generous 2 marks, just be able to be typing things into your calculator. Okay, cool. Let's move on. Question 3. In January 2018, an art collector bought an antique painting. In January 2020, he sold it for £17,640. Assume that the value of the painting increased by 5% each year. Calculate the art collector's profit. You must show your working. Okay, so this appears to be a reverse compound interest question, doesn't it? Because we're applying 5% over a number of years. How many years is it? 2018, 19, 20, so 2 years. So normally when you do a compound interest question, you take your value and you multiply it by your multiplier, and then you raise that multiplier to the number of years that you've got, isn't it? Okay, so in this case, I don't know what the amount is. I'm just going to call it A for now. I'm going to multiply it by a multiplier of, well, if it's 5% a year, 5% increase is 1.05 as a multiplier, isn't it? So that's times 1.05 raised to the power of the number of years, which is 2. And I know that is equal to 17,640 because it tells me in the question. Okay, yeah, so that came from the percentage increase, and A is what we're trying to find, isn't it? We want to try and find we want to find the profit. So I need to find A, and if I take it away from the amount, then I should get the profit, shouldn't I? Okay, so I need to work this backwards to find A, and I can do that just by rearranging. Divide both sides by 1.05 squared. Okay, and then it will disappear on this side and then just reappear on the other. So A is going to be 17,640 divided by 1.05 all squared. Okay, so typing that into the calculator, 17,640 divided by 1.05 squared comes out to 16,000. So then his profit then is going to be the difference between those two amounts, isn't it? What he paid for it, what he sold it for minus what he paid for it. Okay, so 17,640 minus 16,000. That's a difference of 1,640. So that's going to be his profit then, isn't it? He's made 1,640 on the sale. Okay, nice work. Question 4. 3 regular polygons meet at a point. 2 of the polygons are pentagons. Find the number of sides of the third polygon. So you must show your working. Okay, so presumably then, like this is the pentagon, this is the pentagon, and this is, I don't know what it is. Okay, so what do we know about pentagons? Well, we can easily find the exterior angle of a pentagon. So pentagon exterior you can find interior angle straight away using the formula, but it's so much easier to find the exterior angle first and then find the interior angle, because the exterior angle is just a simple formula. It's 360 divided by the number of sides, in this case 5 sides, so that's going to be 360 divided by 5, which gives you what's that, 72. So I know that angle, so like of a pentagon, then we're working out this angle here. That's what 72 is, isn't it? Okay, and once we know that, it's really simple then to work out the interior angle, because you just take it away from 180 because the two things lie on a line, don't they? So then the interior angle is equal to 180 minus 72, which is 108. Okay, now like I say, you could just go ahead and use the formula n minus 2 times 180 divided by n. But it's longer, isn't it? I find it much easier to work out the exterior angle first and then the interior angle. So you might even need the exterior angle as part of your problem. I don't think you do in this case. But anyway, that's 108. So that means that angle there is 108 and that one there is 108. So then it's a simple matter of finding that angle there then by angles at a point adding up to 360. So polygon interior angle is going to be what's that then? So I'm going to take the 360 minus my 2 lots of 108 then, isn't it? Okay, so 208s are 216, so that's 360 minus 216, making the interior angle of my polygon to be, what's that, 104. 144. Okay. Now again, I could then sub that into the really complicated interior angle formula to find the number of sides. But again, I'm just going to work out the exterior angle because it's easier. So the exterior angle then is going to be 180 minus 144 for the same reasons we said earlier. So that comes out to be 36. Okay, and then because the exterior angle equals 360 divided by the number of sides, then the number of sides is going to be those two things kind of rearranged. You can just rearrange this, can't you? So exterior angle and n, you can just switch them around. So you can say the number of sides is just equal to the 360 degrees divided by the exterior angle of 36, which comes out to be 10. Okay, so I guess it's a decagon, isn't it? So 10 sides. Question 5. The scatter diagram shows the midday temperature at 13 different heights on a mountain. Plot on the scatter diagram another point. There's 2 points we need to plot. Height of 500 and the temperature of 88. So find 500. There's 500. And read up until you get to 8.8. So 8.8. And actually you've got like 5 squares between each one of these. So 1 unit divided by 5 is 0.2. So you're going up in 0.2. So 8.8 is like one little square below 9, isn't it? So I'm going to have a point there. Okay, so my first point. And then my second point is going to be at 1,580 at 1.2. So 1,580. Again, you've got 100 units between here, represented by 5 little squares. So each one of those is going to be worth 20. So 1,580 is going to be 4 squares up from 1,500. So it's there. You've got a height of 1.2. And that's 1 and 1 little square, then, isn't it? So it's going to be... My eyes are going a bit doolally, going a bit crossed on here. Okay, so there we go. It goes there on the end. Oops. So yeah, we're good. Right, so they're my 2 points worth 2 marks. That's nice. So describe the type of correlation shown in the scatter diagram. Well, you can see, as you look at it from left to right, the line is sloping downwards. So this is a clear example of negative correlation, isn't it? So what type of correlation is it? It is negative. Negative correlation. Okay, so by drawing a line of best fit, estimate the temperature at 1,000 meters. Right, so my line of best fit has to kind of follow the basic trend of the points. Try and angle it so it kind of goes through your data so that there's about the same amount of points on either side. So something like that maybe. Now you do get a fair bit of wiggle room for these. It's not an exact science. Okay, so something like that. So I've got points on either side. It kind of vaguely goes through the trend of my points. That's good enough. Like, you will get quite a bit of leniency on your line, so it doesn't have to be exactly like mine. So when you're marking yours, you have to kind of mark yours against your line of best fit. So there isn't one answer for C. The examiners will look at your line of best fit and how you have read up from 1,000 and across. So, you know, 2 people can write down exactly the same answer. One of them will get it right and one of them will get it wrong, because it really depends on their own line. Okay, so on my line, it kind of changes direction there. Oops. Okay, it's a good idea to draw these marks on. It shows method. Okay, so it ends up there. What's that? 5.6. So I'm going to say that the temperature at 1,000 meters is going to be 5.6 degrees. Pretty chilly. Right, circle the outlier on the scatter diagram. Your outlier is the point that doesn't kind of match all the other points. It's kind of a bit of a billionomates. It's this one up here, isn't it? Okay, that's my outlier. Explain why using the scatter diagram to estimate the temperature at 1,800 meters may be unreliable. Well, if you have a look at your first and last point, your first point is here and your last point is the one we plotted, it's here, which means we've got points plotted from here up to here on our scale. Now, beyond that, we haven't got any points. Now, we could imagine that this line continues in the same fashion, but that is an assumption, and we may well be wrong. So when you try and read values off beyond your data set, it's called extrapolation. So anything beyond here is called extrapolation. And it is unreliable. Okay? Just interest, if you do look up values between here and here, it's called interpolation. Interpolation. And that is good. Interpolation good, extrapolation bad. So that's my reason. 1800 lies beyond the last point on the graph, so we would be extrapolating. Find the percentage of the 15 temperatures which are below 6 degrees centigrade. Well, where is 6 degrees centigrade? It's here. So let's just draw that one. So this is my cut-off line at 6. So which points lie below that? You've got 1, 2, 3, 4, 4, 5, 6 points below 6 degrees. So what is 6 out of 15 as a percentage then? So the percentage is going to be 6 over 15 times 100 then, isn't it? What's that? 6 over 15. 6 divided by 15 times 100 comes out to be 40%. 40%. Okay, so a lot of marks on that. 10 marks, a tenth of the paper just on that. So, wow, wasn't that tricky a question, was it? Let's move on. Question 6. A machine can dig on average 2 centimeters of a tunnel each minute. It operates 24 hours each day. Work out how many days it should take to dig a tunnel of length 3.5 kilometers. Give your answer to the nearest day. Okay. So we got mixed units here first off, so that's what we're going to have to take care of that. That's in centimeters and that is in kilometers, isn't it? Okay, so one of them is going to have to change. I don't know which is best to do at the moment. Maybe if we convert 3.5 kilometers into centimeters, it's going to be a lot of centimeters. Okay, so what's this in centimeters? 3.5 kilometers. Well, to get it into centimeters, 3.5, there are 1,000 meters in a kilometer, and there are 100 centimeters in a meter. So we're times in 1,000 and then times in 100. So 3.5 times 1,000 times 100. That comes out to be 350,000. Okay, so we've got 350,000 centimeters to drill. Okay, now we're doing 2 centimeters each minute. So then the number of minutes is going to be 350,000 divided by 2 then, isn't it? Because we're doing 2 each day. So divide by 2 comes out to be 175,000. So then the number of days, now we can go from minutes to days by dividing by the number of minutes in an hour, which is 60, and dividing by the number of hours in a day, which is 24. Okay, so it's 175,000 divided by 60 divided by 24. So what is that then? That comes out to be 121.5 and change. I'm just going to round it off to Well, I need to round off to the nearest day, don't I? So that is to the nearest day, 121.5. That rounds up, doesn't it, to 122 days. So 122 days. It's going to take a while. The machine actually digs an average of 2.5 centimeters of tunnel each minute for most of the time, and an average of 1.5 centimeter each minute for the rest of the time. Okay, so how would this affect your answer to part A? Okay, so if it digs 2.5 centimeters on average for most of the time and 1.5 on average for the rest of the time, that means that the average of those two things is going to be more than 2, isn't it? Because if you've got if they were the same amount of time you added them together, 2.5 and 1.5, that would give you 4, and then divide it by 2 to find an average, give you 2. But what we're saying here is that for most of the time, this one, it's this one. So there are more 2.5s than there are 1.5s. So that means that your overall amount is going to be bigger than 4, which means this is going to be bigger than 2. Okay? So if it's bigger than 2, we're going to be dividing by a number which is bigger than 2. So we're going to get a number which is smaller than 2 there. So the number of minutes is going to be less. So we're going to be dividing a smaller amount by the same amount, so then that is going to be smaller, so our answer is going to be less. So it means that on average it's going to take less than 122 days. Okay, so I would say it would take fewer days to complete. Question 7. The diagram shows a square-based pyramid and a sphere. The pyramid has a base length of 12.3 centimeters and a perpendicular height of 15.7 centimeters, and the sphere has a radius r. The pyramid and the sphere have the same volume. Work out the radius of the sphere. You must show your working. Okay, we've been given the formula for pyramids and spheres, which is handy, so we don't have to remember them. Right, okay, so we know that these two shapes have the same volume, so these two things are equal in volume. Now we've got no measurements on the sphere, and we need to find out what r is, so we're going to deal with the pyramid first. Okay, so we're going to work out the volume of the pyramid, and then we're going to work backwards with the sphere formula to find the radius. Okay, so let's crack on with that then. So the volume of the pyramid is, what's that then? So the formula is down here. It's 1/3 times the area of the base times the perpendicular height. Okay, so 1/3 times area of the base times the height. Now, this particular pyramid is a square base pyramid, so the area of the base then is going to be this area here, whatever that is, and because it's a square, it's quite easy to find. That's just going to be 1/3 of the area of the base, then is going to be 12.3 times 12.3, isn't it? 12.3 squared. And then the height is 15.7. 15.7. Okay, so throwing that into the calculator, we should be able to find out the volume fairly easily. So 1/3, I'm just going to divide everything by 3 at the end, I think. So 12.3 squared times 15.7 divided by 3, and that comes out to be 791.75 equals 791.751. Okay, and then what we're going to do now, so now we need to work out the volume, well, the radius of the sphere, don't we? So we know that the volume of the sphere is equal to 4/3 pi r cubed. Okay, so subbing in what we know that then that is 791.751 there, and we want to get r by itself, don't we, really? So we're going to have to rearrange this to make r the subject. Okay, So I'm going to multiply through by 3 and divide through by 4 pi basically. So I'm going to divide by 4 pi and times by 3, aren't I? Okay, and that will cancel those all out on the left and the right, and then I'll get 791.751 over 4 pi times 3 then, aren't I? Okay, so the 3 comes up and the 4 pi goes down, and that is equal to r cubed. Okay, and then so to find r, we're going to have to cube root that then, aren't I? If I cube root both sides, then I'll get the cube root of all of that. Okay, r is the cube root of 791.751 times 3 divided by 4 pi, all cube rooted. Right, so let's type that in. So I'm going to use the root sign first. So cube root, shift, there it is. Shift cube root, and then I'm going to use the fraction key. 791, well, it's actually my answer, so I'm just going to press answer, times by 3, and on the bottom I'm going to have 4 pi. Okay, what's that then? That's 5.7389. I'm going to just round it off to 3 sniffing figures. I'm going to say r is 5.74. R equals 5.74. Unit centimeters. So 5.74, final answer. Question 8, here is a table of values for y equals x squared plus 2x minus 2. So we've got a quadratic equation here. Now, weirdly, they've given us all of the values here. We don't have to go and find them. So often we have to go and find some missing ones, but they've got the whole table here. So we just need to plot them really, don't we? Right, so we're going to take each pair in turn and plot them. So the top one is the x coordinate, the bottom one is the y coordinate. So the first point we need to plot is minus 4, 6. So minus 4 along the corridor up the stairs is there, look. Minus 4, 6. Minus 3, 1 is there. Then minus 2, minus 2 is there. Minus 1, minus 3 and there. 0, minus 2. 1, 1 and 2, 6. Now, as I said, it's a quadratic equation, so I'm expecting a parabola when I draw them. A parabola is like a U-shaped curve, isn't it, like that? And that's what I've got here. I hope you can see that. So we're going to draw a parabola through these. We're going to draw our curve through these points. Now, parabolas don't have pointy bottoms. They don't have square bottoms. So you need to try and make a nice rounded parabola at the bottom. These are not correct. And you need to join them up with a smooth, continuous line. It takes a bit of practice to do this, but you know, you can do it, I'm sure. Now, you don't want to miss the points. That's important. Doesn't matter if you're a little bit wonky, but you should skewer each of your points. And you shouldn't do what's called feathering, where you have like multiple goes at drawing the line. So if there's more than one line on the graph, you can get marked down for that. Okay, so just bear that in mind. So I've drawn a nice smooth curve. It's passing through each of my points. It's continuous. I haven't feathered. It hasn't got a pointy bottom. We're good to go. Right, let's answer the question. Write down the equation of the line of symmetry for this graph. Well, parabolas have a line of symmetry running through their minimum or maximum point, their turning point. So here, that's at minus 1, minus 3, isn't it, this point here. So our line of symmetry runs down through my shape like so. Okay, now what is the equation of that line? Now any vertical line is going to have the equation x is equal to something, and that value is the value it passes through the x-axis. In this case it's minus 1. So this is the line x is equal to minus 1, so that's my answer. X equals minus 1. I use your graph to solve the equation x squared plus 2x minus 2 is equal to 0. Now remember, we drew y is equal to x squared plus 2x minus 2. So basically what we're trying to do is find the point of intersection between that and the line y is equal to 0. In other words, y equals 0 is the x-axis. So we're looking for the points where the graph passes through the x-axis. This is often called the roots of the quadratic. So they're there and there, look, where it passes through the x-axis. So we just need to read those off as best we can. Now my first one is at minus 2 I'll make that minus 2.7. Now, you have to be accurate to the nearest little square, okay? But, you know, use your answers from your graph rather than mine from my graph. And this one on the right, I'm making 0.8, okay? So you will get a bit of leeway depending on how you draw on your graph. You usually like have to draw it within 1/2 square or something. You know, it has to be within half a square of where it has to, actually has to be. But you will get some leniency depending on how you draw on your graph to start with, okay? So if you haven't got quite the same answers than me, don't worry, as long as you're reading them from your own graph, you should be fine. Question 9, points A, B and C lie on the circumference of a circle, centre O. Angle ACB is 90. Now ACB is 90, that's already marked. ACB is 90 is this one here, isn't it? And then what else we've got? AC is 6.4. They've already drawn that on as well, it's there. And BC is 3.7. Now it's always a good idea just to go through these and just double check all the measurements they give you are actually on the diagram, because sometimes they're not, and if they're not, it makes it really difficult for you to see the solution. Now it says work out the circumference of the circle. You must show your working, okay? Well, the formula for working out the circumference of a circle, C equals pi d. Cherry pie delicious, apple pies are too. So C equals pi d is the one we want. But we don't know the diameter yet, so we need a diameter in order to work out the circumference. Now the diameter is this distance here, isn't it? Okay, which we haven't been given, but we have been given a right angle triangle of which we know 2 sides. Okay, so we can find the side AB using Pythagoras theorem, can't we? So Pythagoras theorem says c squared equals a squared plus b squared. So my A is 3.7 and my B is 6.4. So I'm going to square those two, add them together, and then square root, and I should get C. So type that into the calculator. Square root of 3.7 squared plus 6.4 squared. So that gives me 7.39. Okay, so I'm going to say C equals 7.39. Okay, I just realized I'm using the same letter here. That's not very good practice, is it? I'm just going to change my C handily to a D. Okay, so the diameter squared is equal to my 2 squares, a squared plus b squared. So the diameter is 7.39. So then I can sub that into my formula for finding the circumference. So the circumference is going to be pi times 7.39. Now I'm just going to use the full calculator display I worked out from the last time. So I'm just going to type in times pi on the end to get it as accurately as possible. So that comes out to be 23.2. So the circumference then is 23.2 meters, I guess. 23.2. Question 10. A student is researching the difference in how much exercise adults and children do. To collect their data, the student interviews the first 25 people found on the high street at 11 AM on a Monday morning. Make 3 different criticisms of the student's method for collecting data. Well, first off, it's a very odd time to be doing it. They're doing it on a Monday morning at 11, so that excludes all the students who are going to be at school and all the people who are out at work, because 11 AM is working time for most people. So the only people you're going to meet is grannies, isn't it, really, on the streets? Or mums, or stay-at-home parents, or, you know, not most people. So basically I'm going to say it's not a random sample. As workers and school children are excluded due to the time conducted. So that's my first reason. What else? Well, 25 is not a massive sample size, is it? So it's a small sample size. Small sample size. Okay, so that's a criticism as well. It should be bigger really to get everyone's opinions. 25 isn't really that many. And I suppose the other thing is, because you want to look at the difference between adults and children, you probably want to have equal numbers of both adults and children. So want equal numbers of adults, children. So data can be compared. Okay, so they're my 3 reasons. Okay, it's a ridiculous time. Most people won't be around to take part in the survey. The sample size is small, and we want equal numbers of adults and children so the data can be compared. Here is the data collection table that the students used. Hours exercise in a week, adult tally, child tally. Okay, make one criticism of the student table. Well, my criticism is going to be the fact that the boundaries overlap. If you look at that, which boundary does 2 belong in? Does it belong in the 0 to 2, or does it belong in the 2 to 4 category? So I'm going to say class boundaries overlap. It should be 0 is less than or equal to h, which is less than 2, etc. Okay, so yeah, so if you use a greater than or equal to sign on the left and a strictly less than on the right, then the 2 belongs in the second group and it doesn't belong in both groups. Okay, so that's an error there that should be corrected. Question 11. Jamie buys fence panels that fit tightly together. And there's a bit of a diagram of how they look, little wavy looking things. Each panel has a length of 1.8 meters, correct to 1 decimal place. Jamie measures the length of the garden as 42 meters, correct to the nearest meter. Work out the minimum number of panels Jamie should buy in order to be certain that there are enough panels for the length of the garden. Show how you decide. Okay. Right, now this is a limits of accuracy question here. You know, you can tell because of these bits here, correct to the nearest meter and correct to 1 decimal place. Okay, so that means these values have been rounded. So when they're talking about the length of this panel here being 1.8 meters, what they actually mean is that L can take on a range of possible values. If you think about a number line with 1.8 marked upon it, now if you're going up in 1 decimal places, then the next one up on the scale would be 1.9, and the one below it would be 1.7. Now the values that round to 1.8 are going to be the ones that are halfway between those or nearer. So kind of this area, this is the bit that rounds to 1.8. Okay, so the smallest value that rounds to 1.8 is 1.75, halfway between 1.7 and 1.8. And the other one is, the other boundary is going to be 1.85. Now strictly speaking, 1.85 rounds up, but it's still the boundary that we use. So L, our value there, must lie between these two. So greater than or equal to 1.75 or less than 1.85. Okay. Now if we do the same thing for the length of the garden, let's call that G. So then the garden is 42 meters, correct to the nearest meter. So if I go 1 meter up, I'd be at 43. If I went 1 meter down, I'd be at 41. So the bits that then round to 42, this area here, is going to be halfway between 41 and 42, which is 41.5, and the other boundary is going to be 42.5. Okay, so then G, the length of the garden, is going to be greater than or equal to 41.5 or less than 42.5. Okay, so work out the minimum number of panels Jamie should buy in order to be certain that there are going to be enough panels. So I'm going to have to take the length of the garden and divide it by the length of the panel. Now I want to consider the worst case scenario with the maximum number of of panels he's going to need. So in order to do that, I'm going to take the largest possible width of the garden and the smallest possible width of the panel. That's the worst case scenario, isn't it? Because that's going to require the most number of panels. Then if the panels are at the smaller end and the garden's at the maximum end, that's going to be the most panels that you're going to need, isn't it? So then panels required is going to be my upper bound for the garden, which is 42.5, divided by my lower bound for the panels, 1.75. I mean, if you can't figure this out, you can just do all four combinations. So like kind of divide the upper with the upper, the upper with the lower with the upper, the lower and the lower, and see which one comes out the most. Okay, but I've kind of figured it out, so you only have to do one calculation. So what's that then? 42.5 divided by 1.75. Okay, and that comes out to be 24.3. Okay, so you'd have to round it up, aren't you? No, 24.3 rounds down, but if you rounded it down and only had 24 panels, you can have a gap, aren't you, at the end of your garden, which hasn't got a bit of fence in it. So you're going to have to round it up to 25 and saw a bit of it off and put that bit in, haven't you? So I'm going to be using 25 panels, okay, as a maximum. Okay, now if you'd have just gone ahead and divided 42 by 1.8, you would have got 23.3, which you'd be tempted to round up to 24, and you've got the answer wrong, haven't you? So it's 25 panels and not 24. And like I say, if you can't figure out which limit to use, then just divide all four and just check them all. You'll find which one is the highest or the lowest. Okay, let's move on. Question 12a. Points A, B and C lie on the circumference of a circle. EAF is the tangent of the circle. Write down the values of B, C, A, giving you a reason for your answer. Okay, so where's B, C, A? Well, here's B, there's C, there's A. So B, C, A, B, C, A. We need to find this angle here. Okay, sorry, the diagram got a bit mangled when it got printed out. So you've got angles there, 53, 78 and 49. Okay, on the line there. They're all like angles on a straight line, should add up to 180. Okay, now we want that angle there. Now I know straight away what it is because I know my alternate segment theorem. So this angle here is going to be the same as this one using the alternate segment theorem, isn't it? So I know straight away what that is. That angle BCA is going to be 53 degrees, and because of the alternate segment theorem. Part B says point G, H and J lie on the circumference of a circle, centre O. Angle GOJ is 52. Angle GJH is X. Lines JO and GH are parallel. Find the value of X. You must show your working. Okay, so all that information I was just checking is already on the diagram. GOJ is 52 is marked here. Angle GJH is equal to X. That's there, look. And we've got the two parallel lines marked. Lines, they're parallel, they've been marked here, look, and here. Okay, so they're already on the diagram. Now we need to find the value of X. So that angle down there, what's that one? Now, first off, I know that, well, I'm just looking at it and thinking about what I can find. So often these questions, don't focus on the thing that you want to find. Just think about what it is you can find first and then see if you can work it out from there. Okay, so first up I can see that I've got an angle subtended at the center, which is 52, and an angle subtended at the circumference over here, look. Okay, now these two are not equal. Now normally these ones look more like this. If you watch Star Trek, it's like the Star Trek insignia. So that angle there is twice that one, isn't it? The angle at the center is twice the angle at the circumference. So that means that angle JHG is equal to 52 divided by 2. So that is going to be 26 degrees. And the reason for that is angle at center is twice angle at circumference. Okay, so that's that. Well, so now I know that that one must be 26. So I guess I know this one as well because of parallel lines. When you've got a pair of parallel lines and a line crossing them, then this one and this one are called alternate angles, and they're equal, aren't they? And that's what I've got here. So 52 and OGH are alternate, so that must be 52 as well. Okay, and that's because they're alternate angles. Alternate angles. That's my reason. So that one there is 52. And now how does that help me? I guess I want this at this angle here, don't I? Okay. Now I can find that one because OJ and OG are both radii. So that triangle JOG is an isosceles triangle. So if you think about it, here's O, here's J, and here's G. Now J and G are both on the circumference, so that means that these two are radiuses, so they're both the same. So that means this is an isosceles triangle. And I know that that at the top there is 52, so then that means I can find these two then, can't I? So what angle is that? That's OGJ. So I want angle OGJ, and that is equal to it's going to be 180 minus 52 divided by 2 then, isn't it? So 180 minus 52 over 2. Okay, what's that then? So 180 minus 52. 180 minus 52, and that's 128 to share out between those two bottom angles. That's 64 then, so there must be 64 each. Okay, so that's 64 and that's 64, so that means that's 64 over there. Okay, so now I can work out the angle that I'm looking for. Now I can work out GJH. I can just use the angles in a triangle. So then JGH then, I'm going to use angles that add up to 180. So if I take 180 and I take away the two other angles in the triangle, one of which is 26, and the other which is the combined angle of 64 and 52, isn't it? So 64 plus 52 kind of added together. That's my two angles then, isn't it? If I add those together and take it away from 180, I'll be left with X. Okay, so what's that then? So 26 plus 64 plus 52 comes to 142, and take that away from 180, that's 38 degrees, isn't it? Okay, so JGH is 38, and that's the answer I'm looking for. I'm looking for 38. Okay, so it's quite tricky, that one. You have to kind of work your way around it a little bit. Like I say, I didn't even think about what X was first off. I have just thought about what I could find, and then once you do that, then normally you know, the thing you actually want to look for kind of falls out of the problem eventually. Okay, so don't get hung up too much on the thing you want to find. Just find what you can find and work your way around the diagram until you get to where you need to get to. Question 13, here's a restaurant's menu. So you've got a bunch of starters, a bunch of mains, a bunch of desserts, some of which are vegetarian. A 3-course meal consists of 1 starter, 1 main, 1 dessert. Work out how many different 3-course meals can be chosen from the menu. Okay, so number of choices. It's quite simple, these questions. Number of choices altogether. Now, how many choices you got for your first course? You got 1, 2, 3, 4, 5 starters. So I've got 5 starters. I've got 1, 2, 3, 4, 5, 6, 7, 8 main courses, and I've got 1, 2, 3, 4, 5, 6, 7 desserts. So 5 times 8 times 7. If I just multiply all those together, then that is my total number of different combinations that I can get then, isn't it? So what's 5 times 8 times 7? 5 times 8 times 7. That comes out to be 280. So there are 280 different combinations that I could choose from that menu. Okay, spoiled for choice. Right, now part B says find the fraction of the 3-course meals that are completely vegetarian. So coming back to the menu, now we've got 2 vegetarian starters, we've got 3 vegetarian mains, and we've got 2 vegetarian desserts. Okay, so number of combinations of veggie meals, so number of veg choices is going to be 2 times 3 times 2, and that comes to 12. So you've got 12 choices there altogether. So what is that as a fraction of the total menu then? So there are 280 courses altogether. So then the fraction that is veggie is my 12 veggie dishes over my 280 dishes altogether. So 12 280s. Now you could cancel that down, but it doesn't say that you should. But you know, you could just tap it into your calculator and work it out. If you did, it was 3 over 70, but not really necessary to do that. Could have just bailed out at 12 over 280 because it doesn't ask for it in its lowest terms. Question 14, we've got x plus 2 times 3x plus a times bx plus 3, and that's equal to 6x cubed plus 11x squared minus 17x minus 30, and we need to find the values of a and the values of b. Okay, now I think what we're going to do here, we've got triple brackets, which I'm going to try and multiply out as best I can and then compare them with the other side to see if I can work out what the values of a and b are, using a technique called comparing coefficients. So I'm just going to start with one side. So I'm going to start with the left hand side of this. I don't want to deal with everything all at once. So I'm just going to start with the left hand side. So I've got x plus 2 times 3 times 3x plus a times bx plus 3. So I'm just going to ignore the last bracket and just kind of do FOIL on the first 2 brackets. So just multiplying that with that, that with that, that with that. So what I get is x times 3x, which is 3x squared, and then x times a, which is ax, and then 2 times 3x, which is 6x, and then 2 times a, which is 2a. Okay, so that's what I get when I multiply out those 2 terms. Okay, and then I need to carry on multiplying it out. Now I need to multiply everything in the first bracket with everything in the second bracket. Okay, so I'm going to start off by multiplying everything through by bx and writing it down first. So 3x squared times bx, that is 3bx cubed. And then I've got ax times bx, which is abx squared. And then I've got 6x times bx, that's going to be 6bx. And then I've got 2a times bx, which is 2abx. Okay, so I've multiplied everything in the first bracket by bx, and now I'm going to multiply everything in the first bracket by 3. Rather than writing a big long line, I'm just going to drop down the line, and I'm going to start doing it from here. So I kind of, you'll see why I'm doing it that in a sec. So 3 times 3x squared, that is 9x squared. And then I've got 3 times ax, that is 3ax. And then I've got 3 times 6x, which is 18x. And I've got 3 times 2a, which is 6a. Okay? Right, so now we need to kind of combine all those together. So you can see I've got terms in x, I've got terms in x squared, I've got terms in x, which is here, 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 and here, and then I've got a term in, well, a number on the end, which is our constant on the end. Now what I want to do is I want to compare that to this thing up here that we wrote and that we had up here. So that is all equal to 6x cubed plus 11x squared plus, right, all 4 of these are going to be, oh sorry, minus. Let's going to come to minus 17x, and then I've got minus 30 on the end. Okay, so if you think about it, that 3bx cubed matches up with this 6x cubed. So comparing coefficients, we call it. Compare coefficients of, first off, x cubed. What's that going to give us? So the x cubed coefficients, I've got 3b on one and I've got 6 on the other. So if these two expressions are equal, then they've got to be equal as well, haven't they? So 3b has got to be equal to 6, which tells me that b is equal to 2. Okay. Now I could look at the second one, but that hasn't got any a's in it, so that's no good. So I'm just going to have a look at this one on the end. So I've got 6a, and that matches up with 30 down here, or minus 30 actually. So comparing the constants, we've got 6a is equal to minus 30. Okay, right, so that gives me a is equal to negative 5. So a was negative 5 and b was 2. Okay, now a lot of this work here was superfluous. In fact, all of this bit in the middle, look, all this bit in here I didn't actually use or need. Okay, so actually you could have just shortcut this by just thinking about what term delivers you the x cubed term, and just kind of thought, well, that times that times that is going to give me my x cubed term, and that's going to be equal to 6. And what term delivers me the constant at the end? Well, it's that term times that term times that term. So you could have done it that way and saved yourself a bit of work. I've kind of done it long. It's only worth 2 marks, but hopefully you can see why it is what it is, and decide whether or not you want to kind of do a full method or just kind of focus in on the x cubed term or the constant term, and kind of do it a bit faster. Question 15. Use algebra to prove that an odd number multiplied by a different odd number always gives an answer that is an odd number. Okay, now to represent an odd number algebraically, we tend to use things like this. So 2n plus 1, that is always an odd number, because it doesn't matter what n is. If you double n and then add 1 to it, you're going to get an odd number. So let's say n is 2. 2 times 2 is 4, plus 1 is 5, so that gives an odd number. So if n is even, then it gives me an odd number. And if n is odd, let's say n is 3, then 2 times 3 is 6, plus 1 is 7. Okay, so this expression here, 2n plus 1, is a good way of writing down a odd number algebraically. Okay, now in this case we need a second one, so we need 2 odd numbers. So I'm gonna choose a different one, like 2n plus 1. Okay, they're my 2 odd numbers. So I've got 2n plus 1 and 2n plus 1 are 2 odd numbers. Okay, so this is my first odd number, and this is my second odd number. Right, and if I take my 2 odd numbers and I multiply these two together, what do I get? So they have to be different, so where n does not equal m. Okay, they have to be not equal to each other because it says they are different. Okay, so where n is not equal to m, then 2n plus 1 is one of my odd numbers, 2n plus 1 is my other. If I multiply them together, then 2n plus 1 times 2n plus 1, what's that then? So again, we're going to do FOIL on this, this times this, this times this, this times this. That is going to give you 4mn plus 2n plus 2m plus 1. Okay, now how can I show that that's always an odd number? Well, I can say, well, this part here is always even, because we've doubled it, we've times it by 4. This one is always even. This bit is always even. Okay, and we're adding 1 to it. So basically, I've got 3 terms that are all even. So the sum of those, then, all those added together, then, that is going to be an even number. Okay, so what I've got is an even plus an even plus an even plus 1. Okay, so an even plus an even plus an even, so 3 even numbers added together, that is going to be an even number. Okay, and then when you add 1 to an even number, you get an odd, don't you? Because 1 more than the even number is always an odd number. Okay, so therefore always odd. Question 16. Lee bought a house at the start of 2016. Lee assumes that the value of the house, V, can be predicted using the formula V equals 185,000 times 1.035 to the power of n, where n is the number of years after the start of 2016. Part A says, explain how you know that the value of the house is predicted to increase each year. Okay, well, you know it's going to increase each year because you're multiplying through by a number greater than 1. Okay, and so the multiplier 1.035 is greater than 1, so it increases on multiplication. Okay, so if you multiply through by a number bigger than 1, it's going to increase, isn't it? And if it's less, it's between 0 and 1, it decreases. So write down the percentage increase per year that is used in the formula. The percentage increase, then, they're using a multiplier of 1.035, which is the same thing as 103.5% as a percentage. So if it was 100% and you increase it to 103.5%, it's an increase of 3.5%. Okay, because you always start with 100 on percentage increases. So if you've got 103.5, it's gone up by 3.5. Write down the value of the house at the start of 2016. Well, that's got to be this value here, then, isn't it? It's going to have to cost. That's our starting price, which is 185,000 then. Okay. Part D, calculate the predicted value of the house at the start of 2020. Give your answer to 4 significant figures. So 2020 is 4 years after 2016, isn't it? So that is our value of n. N is 4. So then the value is going to be, so the value is equal to 185,000 times 1.035 times to raise to the power of 4 then for 4 years. So that is, what's that, 185,000 times 1.035 to the power of 4. That comes out to 212291.7. Now it's asking our answer here to 4 significant figures, so I need to round that off. Let me just write down the display value first. 212291.7551. I probably wouldn't bother doing this if it was my test. So 4 significant figures then. 1, 2, 3, 4. We're going to round off after that 2 there. Next digit is a 9, which means I have to round up. So my 2122 becomes 2123. And I've got to pad it out with enough zeros to make it the same magnitude as it was to start with. So add another couple of zeros. So that is 212,300 to 4 significant figures. Right, compare with the value at the start of 2016 to show that the formula predicts the house will have doubled in value at some point during 2036. So in 2036, that is n is equal to what? That's 20 years, isn't it? So in 20 years' time, what is the value? So value is going to be 185,000 times 1.035 to the power of 20. So what's that then? Let's just change that power of 4 to a power of 20. And that comes out to be 368,110. I'm going to just do the same thing. I'm going to round it off to 4 significant figures. So that is 368,1 then, I suppose. 00. Now to double, the value is going to have to reach 2 times 185,000. That comes out to be 370,000. Okay, so it's not quite reached that point yet, is it? Okay, so at the start, that's basically at the start of 2036, it's already 368,100, which is not quite double. So that's in 2036. Now in 2037, the value is going to be 185,000 times 1.035 to the 21, which comes out to be, so I'll just change that, 185,000 times 1.035 to the power of 21. That comes out to be 380,994. So again, rounding that off to 4 significant figures, that's going to be 381,000. So it's going to be 381,000. Okay, so between those, so it goes past 370,000 between 2036 and 2037. Okay, so it goes between them, doesn't it? So it was 368 and now it's 381. So it must have gone through 370 at some point between those two dates. Okay, give one reason why this may not happen. Well, it assumes that you get this interest rate of 3.5% constantly for nigh on 20 years, which may not happen because who knows what's going to happen next year, let alone in 20 years' time. So I'm going to say that the interest rate, not really an interest rate, is it? It's the rate of increase may change due to economic factors during those 20 years. Okay, so the rate of increase may change due to economic factors during those 20 years. Sorry, my handwriting's so poor, I could barely read it myself. Question 17. There are 15 sweets in the bag. 10 of the sweets are toffee and 5 are mint. Reese takes 2 sweets at random out of the bag. Work out the probability that Reese takes 1 of each type of sweet. Okay, now we're not replacing the sweet in between. He's just taking 2 out of the bag. So this is without replacement. So that means the numbers change from the various different parts. So the tree diagram is going to look something like this. I'm going to have toffee and mint on the first selection, and then if I choose toffee, I've got a toffee and mint selection second time, and if I choose mint, I've got a toffee and mint selection the second time. Okay, now on the first selection there are 15 sweets in the bag, 10 of which are toffee, so I've got a 10 chance in 15 of selecting a toffee and a 5 chance in 15 to select a mint. On my second selection, I've got 1 fewer sweets. I've only got 14 sweets. Now, if I pick the toffee the first time, I've got 1 less toffee to pick from as well. That means there are 9. but I still got all 5 of the mints in the bag there, so that's going to be 5 out of 14. Now if I go down the mint route, that means I've got 1 less mint and 1 less sweet. So that's going to give me a probability of 10 out of 14 for picking a toffee and 4 out of 14 for picking a mint. Okay, work out the probability that Reese takes 1 of each type of sweet. So which routes are they then? So that is toffee, mint, or mint toffee. They're the ones that I want to find, isn't it? So what is the probability of toffee mint? That's going to be my 10 over 15 times my 5 over 14. And what's the probability of mint toffee? That's going to be 5 out of 15 times 10 out of 14. Notice that these are kind of same numbers but just kind of reversed. Okay, so they're going to give me the same value, aren't they, really? So 10 15ths, 10 over 15 times 5 over 14. That comes out to be 5 over 21. So it's going to be the same for this one as well, isn't it? 5 over 21, because it's the same numbers. So then the probability then of 1 of each is going to be the probability of toffee mint plus the probability of mint toffee, which is 5 over 21 plus 5 over 21. And that comes to 10 over 21, so that's my final answer then, isn't it? 10 over 21. Okay, question 18. The diagram shows a circle centre at the origin. Write down the equation of the circle. Now, this is a very straightforward question because the equation of any circle centre origin is always of the form x squared plus y squared equals r squared, where r is the radius of your circle. Okay. Now, we can see the radius of the circle quite easily because we know this distance from here to here is 3. So the radius is 3, and that means that the equation of the circle is going to be x squared plus y squared equals 3 squared. 3 squared is 9, so the equation of this circle is x squared plus y squared equals 9. Question 19a, write down as a single fraction in its simplest form 4 over 2n plus 3 minus 2n over n squared plus 1. Okay, now algebraic fractions simply follow the same rules as normal fractions. So if you know how to subtract normal fractions, you should know how to subtract algebraic fractions. So for instance, if you had 2/3 minus a half, how would you work that out? Well, the first thing you need to do is you need to find a common denominator. So what's common out of 3 and 2? Well, 3 and 2 is 6, isn't it? So if we put them as a fraction over 6, now 2/3 is the same thing as 2 times 2, which is 4 6, and 2 goes into 6 3 times, so 1 times 3 is 3, and then we subtract, and then that's our answer, isn't it? 1/6. So we need to do the same thing over here. So what is the common denominator of 2n plus 3 and n squared plus 1? Well, if you think about it, what we did here with 3 and 2, we simply multiplied them together to give us that, didn't we? Now, sometimes there's a smaller number, so like, 6 and 9 isn't just 6 times 9 because there's a lower common multiple of them, but generally you multiply them together and that's going to give you your common denominator. Okay, so here we're going to put them as a fraction over 2n plus 3 times n squared plus 1. Okay, and then on the top, how did I get this 4 here? I took the 2 and I multiplied it by how many times 3 goes into 6. In other words, I multiplied this number with this number and I got that number there. And I'm going to do the same thing here. I'm going to multiply this with this, and that's what goes here. Okay, so 4 lots of n squared plus 1, that is 4 n squared plus 1. Okay, and I'm going to minus, how did we get that 3 over here? Well, it was this 1 times this 3, wasn't it? Because that's how many times 2 goes into 6. So doing the same thing here, then this times this then is what goes there. So that's going to be 2n times 2n plus 3 then, isn't it? Okay. Right, so I can get rid of this now. Now you kind of understood where it's coming from. Right, now we just need to tidy this up a little bit, don't I? So I'm multiplying out the various parts of this this expression. So first off, the 4n, 4 lots of n squared plus 1, that is equal to 4n squared plus 4. Okay, so that's the green bit. And then I'm going to minus this bit here then, aren't I? So that's going to be minus 2n times 2n, that is 4n squared. Now just take care here because I've got minus 2n and plus 3, so minus times plus is minus. So that's going to be minus 6n on the end here. So I got that from multiplying out the blue bit. And then that is all over these two things multiplied together. So now I might need to multiply out the bottom terms, but I don't know. So I'm just gonna leave it like that. I might be able to cancel it with something later. So I'm just gonna leave that for now. Just tidying up the top. You notice on the top we've got 4n squared here and another one here. One is positive, one is negative, so they kind of cancel each other out, those two. That leaves me on the top with 4 minus 6n over 2n plus 3n squared plus 1. And then I can factorize out a 2 out of the top, I suppose. So that's 2 lots of 2 minus 3n over 2n plus 3 n squared plus 1. Okay. Part B says simplify x squared minus x minus 12 over 2x squared minus 3x minus 20. Now with this one I've got a quadratic top and bottom. If I can factorize them, I might find I've got some factors top and bottom that I can cancel out. So that's usually the best approach for these. So can we see if we can factorize this into two brackets on the top? So x squared minus x minus 12. Well, 12 has got factors 1 and 12, 2 and 6, 3 and 4. Which pair, if one is positive and one is negative, because it ends in a minus number, so it's going to be x plus x minus. So which pair kind of gives you minus 1 in the middle? I think it's going to be this one here, isn't it? 3 and 4. So if I've got x plus 3, x minus 4, they multiply together to give me minus 12 and add up to minus 1. Okay, and then on the bottom row, can I do something similar? Now here I'm going to have a term in 2x and a term in x, aren't I? And then factor pairs of 20. So 1 and 20, 2 and 10, 4 and 5 are my possibilities, aren't they? Okay, now this time, remember whatever I put in one side, I can maybe multiply with the 2x or maybe multiply with the x. It depends which way you put them in. So which combination is going to give me minus 3 in the middle? I think it's going to be the 4 and the 5, isn't it? So if I put the 4 here and multiply it by 2x, that's going to give me 8x. And if I put the 5 here, that's going to give me 5x. And I want the larger one to be negative and the smaller one to be positive, like that. So I get 2x plus 5, x minus 4. So the 5 times the minus 4 gives me minus 20. The minus 4 times 2x gives me minus 8. The 5 times x gives me 5x. And minus 8x and 5x gives me minus 3x in the middle. So that seems to work out. And you'll notice now then that we've got some common factors top and bottom, because I've got an x minus 4 and an x minus 4. So those two can just cancel each other out. And that's just going to leave me with x plus 3 on the top and 2x plus 5 on the bottom. That's it. That's about as simple as we can get. So I'm going to write that down as my final answer. Question 20, solve this inequality. X squared plus 4x minus 12 is less than or equal to 0. Give your answer using set notation. You must show you're working. Okay, so we've got an equation here. It's a quadratic. It's going to look something like this, isn't it? A parabola. It's going to pass through the x-axis in two places. That's going to be my two roots, here and here, look. And so where is the graph like less than 0? It's going to be this bit here, isn't it? Okay, So for this section, that is where it's going to be less than 0, where the graph is under the x-axis. So what we need to do is find those two roots, and then from that we should be able to form the inequality that we need. Okay. So let's start off by finding the roots, and we can find them. Find the roots of the equation by setting it equal to 0 rather than less than it. That will tell me where the roots are. Roots. So where are the roots? So then factorising that into two brackets. Again, I've got 12 factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. Which pair work here? I think it's that one there, isn't it? So x plus 6, x minus 2 go in there. Okay. So then that's going to give me roots of x equals minus 6 and x equal to 2 then, isn't it? They're my two roots of the equation. So then on my graph, that's got to be the minus 6 there, and that has got to be the 2. Okay. So then my value of x has got to lie between those two values then. It's got to lie between minus 6 and 2. Now it can equal the endpoints because of the symbol we had here. So x lies between minus 6 and 2. Now in set notation, that looks like this. We have a kind of a curly bracket, and we say x such that x lies between minus 6 and 2, close curly bracket. Okay, so that's set notation. So it's the values of x such that x lies between minus 6 and 2. That's how we should set it out. All right. Now, don't skimp on the diagrams. Diagrams help you visualize. I always draw a sketch, and most of my students who don't draw a sketch often get the inequalities the wrong way around or get the wrong region. So it only takes a couple of seconds, and I think it helps you visualize and work out which way around the inequality symbols go. All right, job done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.